Imagine a night sky, far from city lights, where the stars shine with a clarity that takes your breath away. Now picture yourself standing on the surface of a distant world, looking up at a sky that is both familiar and utterly alien. Instead of seeing just one sun rise and set, you witness not one, not two, but three brilliant suns arcing across the heavens. The landscape is bathed in overlapping shadows and shifting colors, as each sun casts its own unique light. This is the extraordinary reality for any planets orbiting Gliese 667C, a star system that challenges our very idea of what a solar system can be. Imagine the days and nights, the seasons, and the rhythms of life on a world with three suns. Each day would be a spectacle of cosmic choreography. Gliese 667C is part of a remarkable triple-star system, where three stars are locked in a gravitational embrace, orbiting each other in a complex and beautiful cosmic dance. These stars are bound together by the invisible force of gravity, moving in patterns that have fascinated astronomers for generations. Located about 23 light-years away from Earth, Gliese 667C resides in the constellation Scorpius, a region of the sky known for its bright stars and mysterious cosmic wonders. If you know where to look, you can spot Scorpius on a clear summer night, its tail curling across the Milky Way. In the vastness of our galaxy, 23 light-years is practically next door. While it may sound distant in astronomical terms, Gliese 667C is one of our closer neighbors, making it a prime target for scientists searching for planets beyond our solar system. The triple star system is made up of two stars that are similar to our own sun, both in size and brightness. But Gliese 667C stands out from its siblings. Unlike the other two, it is a red dwarf, a type of star that is much smaller, dimmer, and cooler than the sun we know. Red dwarfs are the most common type of star in our galaxy, yet they are so faint that not a single one is visible to the naked eye from Earth. Astronomers use powerful telescopes to study these elusive stars, uncovering their secrets and searching for planets that might orbit them. Compared to our sun, red dwarfs like Gliese 667C are tiny, often less than half the sun's size, and they burn their fuel much more slowly. This means they shine with a gentle reddish glow, rather than the bright yellow-white light of our own star. Their light is so faint that, even though they are all around us, they blend into the background of the cosmos. If you could see Gliese 667C from a nearby planet, the sky would be tinged with a subtle red hue, a constant reminder of the star's unique nature. Gliese 667C is only about one-third the mass of our sun, and its surface temperature is roughly half as hot. This makes it a cool, dim star, but one with the potential to host planets in its habitable zone, where conditions might just be right for life to exist. Red dwarfs are the most common type of star in our galaxy, the Milky Way. In fact, if you were to look up at the night sky and somehow see every star, most of the points of light you'd spot would actually be red dwarfs. Even though they're too faint to see with the naked eye, these stars are scattered throughout the galaxy, quietly outnumbering all other types of stars combined. Their abundance makes them a key focus for astronomers who want to understand the structure and evolution of the Milky Way. Red dwarfs are much smaller than our sun. Some are only about a tenth the sun's mass, and their diameters can be less than a quarter of the sun's. Because of their small size, they burn their fuel very slowly, which means they shine with a much dimmer, cooler light. But this slow burn is actually their secret to longevity. While our sun is expected to live for about 10 billion years, red dwarfs can last hundreds of billions or even trillions of years, far longer than the current age of the universe itself. This incredible lifespan makes red dwarfs especially interesting to astronomers. Because they live so long, they offer a stable environment for any planets that might orbit them. Scientists are fascinated by the idea that given enough time, life could have a better chance to develop and evolve around these stars. The sheer number of red dwarfs, combined with their longevity, means that the odds of finding planets with the right conditions for life might be higher than we once thought. Imagine a planet orbiting a red dwarf star. Because the star changes so little over time, the planet could have billions of years of relatively stable conditions. This is a huge advantage for the development of life. On Earth, it took nearly 4 billion years for complex life to evolve. Around a red dwarf, there could be even more time for life to emerge, adapt, and flourish. Some scientists even speculate that the oldest life in the universe could be found on planets orbiting these ancient steady stars. While red dwarfs are cooler and dimmer than our sun, they can still provide enough warmth for planets in their so-called habitable zone, the region where temperatures are just right for liquid water to exist. This is important because, as far as we know, liquid water is a key ingredient for life. Planets in the habitable zone of a red dwarf would orbit much closer to their star than Earth does to the sun, sometimes completing a year in just a few days or weeks. The presence of liquid water is crucial because it acts as a solvent, allowing the complex chemistry of life to take place. On a planet orbiting a red dwarf, water could exist on the surface, in lakes, oceans, or even as underground reservoirs. The red light from the star would give the landscape an otherworldly glow, but the basic requirements for life, energy, water, and time could all be present. That's why, when astronomers search for signs of life beyond Earth, they pay close attention to red dwarf stars like Gliese 667C. These stars are not only common, but their planets are easier to detect because of the way red dwarfs interact with their surroundings. With new telescopes and advanced technology, scientists are now able to study these distant worlds in greater detail than ever before, bringing us closer to answering one of humanity's biggest questions. Are we alone in the universe? Using powerful telescopes, astronomers can detect the subtle wobble of a star caused by the gravitational pull of an orbiting planet. This method, called the radial velocity method, has revealed a treasure trove of planets around Gliese 667C. What's even more exciting is the type of planets they found. Gliese 667C is home to several super-Earths. These are planets larger than Earth but smaller than Neptune. They are likely rocky worlds like our own, but with a greater mass. Some of these super-Earths orbit within what astronomers call the habitable zone. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. It's often called the Goldilocks zone because conditions are not too hot, not too cold, but just right for life as we know it. Three of the super-Earths around Gliese 667c, named Gliese 667cc, 667cf, and 667ce, are particularly intriguing. They lie within or near the habitable zone of their star, raising the tantalizing possibility that they could harbor liquid water, and perhaps even life. When we look out into the universe, some of the most intriguing planets we find are those orbiting close to small, cool stars known as red dwarfs. These stars, like Gliese 667c, are much dimmer and cooler than our Sun, but their planets can be very close to them, and still be in the so-called habitable zone, where liquid water might exist. However, these close-in planets experience a fascinating and unusual phenomenon called tidal locking, which dramatically shapes their environments and potential for life. Tidal locking means that the gravitational pull between the planet and its star is so strong that the planet's rotation slows down until it matches its orbit. As a result, the same side of the planet always faces the star, just like how we always see the same face of the moon from Earth. This process can take millions or even billions of years, but for planets close to their stars, it happens relatively quickly in cosmic terms. The consequences of tidal locking are profound, especially for the planet's climate and weather patterns. With one hemisphere in constant daylight and the other in endless night, the planet's atmosphere and surface experience extreme differences in temperature and light. Scientists use advanced computer simulations to predict what the weather might be like on these worlds, and the results are often dramatic. Imagine fierce winds, massive storms, and swirling clouds as the planet's atmosphere tries to redistribute heat from the scorching day side to the frozen night side. On the day side, the sun never sets. This perpetual daylight means temperatures can soar to blistering levels, possibly hot enough to boil away water or even melt rocks, depending on how close the planet is to its star. The landscape here would be bathed in unending, harsh sunlight, creating a stark, alien environment unlike anything we see on Earth. Meanwhile, the night side is locked in eternal darkness, never seeing the light of its star. Temperatures here can plummet to hundreds of degrees below freezing, creating a world of ice and shadow. Any atmosphere or water could freeze solid, and the landscape would be eerily still, illuminated only by faint starlight or perhaps the glow of auroras. But between these two extremes lies a narrow region called the terminator, the dividing line between day and night. Here conditions might be just right for life as we know it. Temperatures could be moderate, and there might be enough light for photosynthesis. Some scientists speculate that if life exists on tidally locked worlds, it could thrive in this twilight zone, adapting to the unique and challenging environment of a planet forever split between light and darkness. While the habitable zone is a good starting point, the presence of liquid water alone doesn't guarantee a planet can support life. Red dwarf stars like Gliese 667C are known to emit powerful flares, bursts of intense radiation that could be harmful to life. Furthermore, the higher gravity on these super-Earths would mean a denser atmosphere and potentially different atmospheric composition than Earth. Red dwarfs also emit less ultraviolet radiation than our Sun, which could affect the development of life as we know it. Despite these challenges, the sheer abundance of red dwarfs in our galaxy offers a glimmer of hope. Because they are so common, it stands to reason that many red dwarf stars likely host planetary systems, and some of these planets could be potentially habitable. If even a small fraction of red dwarfs have planets like Gliese 667cc, 667cf, and 667ce in their habitable zones, then the number of potentially life-bearing worlds in our galaxy could be staggering. The search for life beyond Earth is one of the most profound scientific endeavors of our time. With new and more powerful telescopes coming online, such as the James Webb Space Telescope, we are entering a golden age of exoplanet discovery. These telescopes will allow us to study the atmospheres of exoplanets like never before, searching for telltale signs of biological activity. They will also help us to better understand the conditions on these distant worlds, and the challenges and opportunities for life. The discovery of planets around Gliese 667c and other nearby stars has ignited our imaginations and fueled our desire to explore the cosmos. While we have yet to find definitive proof of extraterrestrial life, the search itself is a testament to our curiosity and our enduring quest to understand our place in the universe. The universe is vast and full of wonders, and as we continue to explore, we may find that we are not alone. The journey of discovery has just begun. Subscribe to Fact Fusion for more cosmic wonders.